Functions have domains that their domain is the set of real numbers. Which three do not? So which three of the 12 functions do not have a set of all real numbers? So I'm going to go through and we're going to look at each graph and see of the 12 functions. So let's go back to the first one. What's the domain of this one? Of the identity function? Are there any restrictions? No. We got to look, what are the restrictions for domains, algebraically speaking? 0 in the denominator and negative square roots. So this is all real numbers, so the identity function has a domain of all real numbers. Let's go to the next one. The squaring function has a domain of all real numbers. No square root symbols, no even roots, and no zeros in the denominator. So that's not an issue. Let's move over to the next one. X cubed, again looking at the graph, it looks like there's nothing wrong. It should be able to go on forever, but algebraically speaking, no square roots, no zeros in the denominator. Square root function, what's the domain on that? Well, it's from 0 to positive infinity. So that's not all real numbers. I can't put a negative. So the first one is the square root function. Alright, let's keep going. The reciprocal function. I probably should have saved a 3 to the last, but that's okay. Reciprocal function. Got an x in the bottom. Can't plug a 0 in. That's a restriction. It's all real numbers except for x cannot equal 0. So there's 2. How many did the book say had restricted domains?
3.
3. So we got 2 out of 3. E to the x, when I look at the graph, goes on forever in both directions with regards to x, so that looks like all real numbers. Sine, all real numbers, can go on forever in both directions in the x direction. Cosine function looks just like the sine function. The greatest integer function looks wacky, but there isn't a point where x isn't defined. Absolute value function, all the x values are represented, so that's all real domains. And the logistic function. However, if I look at the logarithmic function, now this is the third one we want to add to our list of domain restrictions, is the natural log of x. I can't plug in 0. It doesn't go to 0. Or any negative numbers. This is the graph. So that domain's restricted. So if we look at our textbook, that's what it says, right? It says here very carefully, it shows all 3 of them. There is, which function is that? The natural log function. So let's see what the textbook says, how they define it. Now why is Mr. Adams just reading from the book? I don't know what it says. No. Because I want you guys to get used to reading from your books. It says, imagine dragging a vertical line along the x-axis. If the function has a domain of all real numbers, then the line will always intersect the graph. You could use the trace function. The trace function points out that the following have holes in their x domain, right? So 1 over x, the square root of x, and the line of x. And we'll talk more about their domains. Part B says one of the functions has a domain of set of all reals except 0. Why? Part B says it's 1 over x. Why? Well, you can't put 0 in the denominator, that's why. Part C then says, which of the 2 functions can you have no negative values? Well, part C, it says right here in your textbook, the function the square root of x and the natural log of x have no negative numbers in the domain. We already knew that about the square root function. While 0 is in the denominator, though, of the square root function, right? Because 0 squared equals 0, so you could take the square root of 0. We can see by tracing, though, that it's not a part of the natural log function. And when we go to logs, I'll explain all that to you. The natural log function is a logarithmic function with a base of e. And when you look at that, you'll see why we have to restrict the domain. Well, it's a little more complicated than that, but we'll talk about it when we get to logs. So for now, we know that the domain, both of those, can't have any negative values. And you can't have 0 in the natural log. Okay? Any questions on that?